In this episode, we'll be talking about chemical bonding. Chemical bonding is an important topic in chemistry that requires holistic understanding. A chemical bond is a lasting attraction between atoms, ions, or molecules that enables the formation of chemical compounds. Several reasons arise for chemical bonding, and we'll talk about those reasons one by one. One of them is the need for elements to attain noble gas configuration, that is the octet or the duplet configuration. All elements want to be noble. When talking about the noble gas, we are talking about the group 8 elements, that is the helium, neon, argon, krypton, xenon, and radon. All elements tend to achieve this noble state by either losing or gaining electron. And naturally, elements will lose the electron or gain electron that favors the least energy. So, like we are saying, all elements want to be noble. Every element wants to attain the octet or the duplet configuration. Let's try to write some of the first 20 elements and let's see how this obeys the rule of losing and gaining electron. Looking at the first element, which is should be what? Hydrogen. We all know for the symbol for hydrogen is H, that's 1. Hydrogen is having only one electron because it's the first element on the periodic table. And if we want to draw the shell configuration, we can just draw a circle to show the shell, then put one electron there. What we are trying to say is that hydrogen is having only one electron. So in order to talk about whether we want to talk about the duplet state or the what or the octet state, then it is very important to know that hydrogen can either lose this one electron and become empty. Are you getting me now? Or gain an extra electron and it become what? 2. So if hydrogen lose one electron, it become empty. If it gains and one electron more, it becomes what? Full. So anytime anything gains electron, we should know that that thing should be what? Negative, because electron itself is negative. But when an element loses electron, it becomes positive. The reason is that electron on its own is negative. So gaining electron makes you negative and losing electron makes something positive. So the thing is that hydrogen can either lose electron to form an empty orbital or it gains electron to form what? A duplet state. Are we getting that now? And this is like one of the foundation for identifying metals and non-metals. Because we want to talk about, we say metals are elements that what that ionizes by losing electron. So metals are elements that ionize by losing electrons. So looking at this, hydrogen can either lose or gain the electron. So you can't say hydrogen is a metal. So why, if you are talking about non-metals? So non-metals are what? Are elements that ionizes by gaining electron. That ionizes by gaining electron. So when something gains electron, we call them non-metals. Why when something loses electron, we call them what? Metals. So it is very important that we know this thing as we talk about the first 20 elements. Another thing we can talk about the metalloids. Metalloids, they can do both. They can either what? They can either lose or they can what? They can gain. So metalloids, they can either lose or they can gain. So looking at hydrogen, the hydrogen can decide to lose or gain. So hydrogen is not can behave like a metal in some cases by having what of H plus or behave like a non-metal by forming an empty orbital by doing that. So the next one is let's talk about helium. Helium is the first noble gas rather, and helium is He, and that's number 2. And looking at the configuration of helium is having a completely filled structure because the first stable state is 2, then followed by what? Followed by 8. So the first 2 followed by what? Followed by 8. Then, so if helium is having 2 now, then it means that it's having a duplex structure. So it can not lose or gain electron at this state. So they are noble gases. In fact, see the word noble. When they call someone noble, it means that maybe a king. So all elements want to be noble. So it's one of the noble gases. So let's talk about the next one: hydrogen, helium, lithium. Lithium is Li, and that's the third element of the periodic table. And trying to split this thing, you can see that 2 comma what 1, 2 comma what 1. That's because the first share can only take 2, the second share can take up to what, up to 8. So if I want to draw the lithium, I will do something of this nature. I will put the 2 here, then the second share I will put 1 on top. So from this thing now, lithium can either lose this one electron and fall back to what, to the helium configuration, that's nuclear configuration, or it can do what, it can gain 7. It can either lose this one or gain what, gain 7. When you gain 7, then it's going to become what, 8. So what do you think is easier? Is it for lithium to lose 1 or gain 7? The energy required to lose 1 is actually lesser than this one. And like I said initially, reaction will favor the parts with lower energy. So lithium will rather lose 1 and become Li plus. Are you getting me now? So with this now, lithium is losing 1 to an element, so that as to form bond. It's not just losing 1 to the atmosphere, it's losing 1 to another element. Because something can lose electron, there's something else will be collecting that electron. It's not that something will just be here and the electron will just jump haywire. No, 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 no. So the next one is beryllium. Beryllium is Be, that's 4 abi, and that's 2 comma 2. The same way that it can lose these 2 or what, or gain what, 6 abi. I think it's easier to lose this to say it form beryllium what, 2 plus. So let's talk about boron now. Boron is B, that's 5 and that's 2 comma 3. Boron can either lose this 3, is that also, and form boron 3 plus, or it gains how many to make 8, to gain 5, boron 5 minus. It can do any of these two sha. So boron, carbon is 6 abi, that's 2 comma 4. Well, carbon can either lose 4 or carbon can gain 4 abi, so it can do any of these two. It's a metal with 2. Carbon, then nitrogen is 7 abi, 2 comma 5. Nitrogen can either lose this 5 or gain 3. See now, before to gain 3, then form N3 minus, so this is a non-metal. So because every element wants to uh, lose or gain electron, that's why they form chemical bond. So let me now give you an example now. If I have sodium and what, and nitrogen now. Sodium is or let me even use a simple element that we've used before. Let me use a lithium and nitrogen, because I've not talked up to sodium. Let's say lithium and what, and nitrogen. See what happens. Lithium and nitrogen. Lithium is actually atom number 3. Nitrogen is naturally what? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. That's number 7. So if I do this one 2 comma 1 and this one is 2 comma 5. So if I do 2 here, then this one is having what, 1 here. So this one is also having 2 here, and this one is having 5. 1, 2, 3, 4, 5. So the problem here is that lithium will either lose 1 or gain how many to come in 7. So lithium will actually require to lose 1. It's easier for that to form Li plus. Why this nitrogen is either going to lose all these 5 or gain 3 to become 8. So nitrogen will to form N3 minus. So in a bit of this one losing 1 and gaining 3, then bonds will arise, because the valence of this one will be 1, and this one will be 3. And if I exchange their number, then they will give me a compound. They form a bond, that's Li3N, because they changed the number. That's Li3N. So that's going to be lithium nitride. I think you get that. Other reasons for chemical bonding are to minimize energy, to gain stability, and to decrease reactivity. One of the branches of bonding is that we have the interatomic bond and the intermolecular bond. Firstly, we are going to talk about the interatomic bond. And the interatomic bonding are forces that hold atoms together and are called cohesive forces. These interatomic bonds may be classified as primary or secondary bonds. The strength of these bonds and the ability to form after breakage determines the physical properties of material. The list of the interatomic bonds that we have are the electrovalent bonds, the covalent bonds, metallic bond, coordinate covalent bonds. And I need to explain this one by one. Having known what metals and non-metals are, let's just define some of these things by rule of thumbs. When talking about electrovalent bond is a kind of bond between metals and non-metals in which there is transfer of electrons. In other words, the covalent bonds are bonds between two non-metals in which there is sharing of electrons. E.g., bonds between two oxygen molecules is a covalent bond. Bond between CO2 is covalent bond because carbon is non-metal, oxygen is non-metal. But bond between sodium and chlorine, that sodium chloride is an electrocovalent bond. That's NaCl because sodium is a metal and chlorine is a what? Is a non-metal. So in electrocovalent bond, there is transfer of electrons from metals to non-metals, and there's always a bond between elements of large electronegativity difference. But for covalent bond is a bond between two non-metals in which there is sharing of electrons. Another one that looks like that is the coordinate covalent bonding. But in coordinate covalent bonding, instead of sharing between two electrons, only one atom does the sharing, e.g. in ammonium 4 plus. So it's a special kind of covalent bonds in which only one atom uh, does the sharing of electron, and the other is actually maybe an empty orbital. And the last one, that's a metallic bond. This one is a bond between two metals. For the metallic bonding, each metal atom gives up its valence electron to form positive ion, and these electrons no longer belong to any metal atom. They are delocalized, so they move freely within the atoms. The coordinate covalent bonds, which is also known as the semipolar bond or the dative bonding, is actually a special kind of covalent bond that forms when both electrons come from the same atoms, like you can see from the configuration below.